Morning, guys. Today we're going to still be taking a look at at page 8 of the Unit 9 Classwork packet, and we're going to take a look at a couple examples of how to approach problems that simply ask us to calculate the trigonometric ratio. All right. So the first one we're going to take a look at is example 1, and we're going to start with the problems that are on the left-hand side, the ones that say sine A, cosine A, tangent A. All right. Now here's what I'm going to do. Just to keep my work straight, I'm going to draw a little angle symbol right there by angle A. That's going to help me when I want to do my labeling of what's the opposite, what's the adjacent, and what's the hypotenuse. Okay, so strategically here, the most important thing I can do is label. I want to say what's O, what's A, and what's H. Those are the abbreviations for opposite, adjacent, and hypotenuse. So my opposite is the one right across from it, so I'm going to label the 5 as my opposite. I know the hypotenuse really easily because it's across from the right angle, right? And so that is going to be 13, and the adjacent is going to be 12. Well, why? Because it's the one that's left over, right? It's the one that's next to it, but it's not the hypotenuse. So I'm going to call that adjacent. Okay. So with that being said, as long as I know my definitions for the trigonometric ratios, right, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, I should actually be I should find this pretty easy, all right? So let's go. So the sine of A would be the opposite over hypotenuse, 5 over 13. The cosine of A should be the adjacent over the hypotenuse. As long as I've labeled correctly, I should get 12 over 13. And last but not least, the tangent of A should be the opposite over the adjacent. Opposite is 5, adjacent is 12. And so look what I've just discovered, guys. The value of a trigonometric ratio is nothing other than a fraction, right? Because what's a fraction but a ratio? Something to something. Now, let's switch our perspective, and instead of dealing with angle A, let's do this for angle C. Okay, so I'm going to make a new list right here. I'm going to say sine C, cosine C, and tangent C. All right, now this is going to require me to switch my labels, guys, at least 2 of the labels. Notice, now C is the angle that I'm basing everything off of. So my opposite, the one that's across from it, is actually my 12. The hypotenuse doesn't change. That's actually still 13. But my adjacent this time is the 5. Now that I've done that, I'm actually ready to calculate my trigonometric ratios. Let's go. So the sine of C is the opposite over the hypotenuse. In this case, that's 12 over 13. The cosine would be the adjacent over the hypotenuse, which is 5 over 13. And last but not least, the tangent of C would be the opposite over the adjacent, which is 12 over 5. Now, the more astute among you may have noticed that with the sine and cosine, when I switch the angle I'm looking at, the numbers just switched places, right? Keep that in mind, because that's going to lead to an interesting discussion in a later video about something called the complementarity of sine and cosine. Oh my god, scary, right? Not really. Let's take a look, guys, at one more example, though, and this one will be example 2, because this one's going to force us to do one small thing first, and that's the Pythagorean Theorem. In this particular triangle, I only know 2 sides, right? That means that it would be very difficult for me to calculate either the sine or the cosine because I don't have the hypotenuse. To find that third side, I need to use Pythagorean Theorem first. Even though it doesn't say to do that, I want to know all my sides. So I'm going to do 9 squared plus 12 squared equals c squared. Notice why I put both of them on the left, the 9 and the 12, because they're both legs. If it were like example 3 instead, where I have a leg and a hypotenuse, I would have to plug in somewhere else, namely for A and C. All right, so let's do this. So 81 plus 144 equals c squared. That means 225 equals c squared. Rad 225 equals c. And because 225 is a perfect square, that means c is 15. So what I'm going to do then, guys, is I'm going to write this big 15 over here, okay? Just because it's going to make our lives easier. Now I'm ready to do some calculation. The first thing they want me to do is find the sine, cosine, and tangent of W. Okay? Now, I want you to make sure you read something in the directions, all right? In the directions, they specifically say, find it as a fraction in simplest form. Guys, this is going to be exactly how it's going to be asked in your Unit 9 test. And if you don't read that part about the fraction in simplest form, trust me, you're not going to be very happy with your result. So please heed my advice. Put a star, highlight, do something to those words, because it's going to be very, very important in order to ensure you get your full points. All right, so in order to find any of these, I need to do some labeling. So I'm going to put my angle by W first. The one that's across is the opposite. The one across from the right angle is the hypotenuse, and the one left over is the adjacent. With that, now I am ready to start calculating. So the sine is opposite over hypotenuse. So opposite over hypotenuse. So 12 over 15. But guys, that's not in simplest form because 12 and 15 have a GCF of 3. So you have to divide both top and bottom by 3 to get that as a fraction in simplest form. Similarly, the cosine of W would be the adjacent over the hypotenuse, which is 9 over 15. But again, there's a GCF of 3, so I have to divide both top and bottom by 3. And last but not least, opposite over adjacent. Well, opposite is 12 and adjacent is 9 for the tangent. So 12 over 9. But again, guys, there's a GCF of 3 for both numerator and denominator. So that reduces down to 4/3. Okay? Then, sorry about that. I think you're a little missing something there. Then, if I want to do exactly the same thing for x, right, sine, cosine, and tangent, I would just move my angle, okay? So the hypotenuse is not going to change, but my new opposite is 9, and my new adjacent is 12. So with that being said, we can go through pretty easily. The sine of x is opposite over hypotenuse, which is 9 over 15. But of course, that reduces down to 3 over 5. The cosine of x is going to be 12 over 15, right? Adjacent over hypotenuse, but that reduces down to 4 over 5. And that tangent of x, that's opposite over adjacent, which is 9 over 12. And that, of course, reduces down to 3 over 4. All right, let me make sure I write these here. So, in sum, no pun intended, okay? In sum, the key here is twofold. Number one, you must remember your trigonometric ratios. You have to remember the definitions of sine, cosine, and tangent, okay? That's non-negotiable, as in sine opposite over hypotenuse, cosine adjacent over hypotenuse, and so on and so forth. Non-negotiable number two is you must label. Label the opposite first. Then label the hypotenuse, you'll know it because it's always across from the right angle, and the one left over is your adjacent. If you combine memorizing the ratios with labeling, you really can't go wrong on this, okay? It's not that bad. In the next example though, or in the next video, we're gonna take a look at what this looks like, more like an EOC level problem where you're gonna have to find side lengths potentially using the ratios and the buttons on a calculator. All right, so stay tuned.